Question: if f of x plus 2 plus f of x minus 2 is equal to root 2 times f of x for every x belongs to R, then prove that f of x is periodic and its period is 16. So this is the question. Solution: so given relation is f of x plus 2 plus f of x minus 2 is equal to root 2 times f of x for every x belongs to real number. So now we need to prove this f of x is a periodic and its period is 16. So first we will see the definition of the periodic function. So definition of the periodic function. So y is equal to f of x is a function. Then if there exists a real number greater than 0, real number t is greater than 0, such that f of x plus t is equal to f of x for every x belongs to R, then we say that the f of x is a periodic function with period t. So here from all those t values, the least positivity, that is least t, is called as fundamental period. So this is the definition of the periodic function. Now to find the period of the function f of x, then what we do is let this be given relation be 1. Now what you do is replace x by x plus 4 in first relation. Then what you get? F of x plus 6 plus f of x plus 2 is equals to root 2 times f of x plus 4. Give this to number 2. Next, add 1 and 2. Add 1 and 2. If add 1 and 2, then what you get? F of x plus 2, this f of x plus 2, f of x plus 2, 2 times f of x plus 2, that is 2 times f of x plus 2 plus f of x plus 6 plus f of x minus 2 is equals to, here root 2 take out common from 1 and 2, root 2 times f of x plus f of x plus 4, f of x plus f of x plus 4. So now what you do is, now in first relation, replace x by x plus 2. If you replace in first relation x by x plus 2, then what you get here? F of x plus 4 plus f of x is equals to root 2 times f of x plus 2. So if you replace x by x plus 2 in first one, then what you get? F of x plus 4 plus f of x is equal to root 2 times f of x plus 2. Now see here, this right hand side of this 1 plus 2 is f of x plus root 2 times f of x plus f of x plus 4. After replacing in 1 x by x plus 2, we got f of x plus f of x plus 4 is equals to this root 2 times f of x plus 2. Now you replace this f of x plus f of x plus 4 by this root 2 times f of x plus 2. So then what you get? This is 2 times f of x plus 2 plus f of x plus 6 plus f of x minus 2 is equals to root 2 times f of x plus 2. So which is equals to 2 times f of x plus 2. Now this 2 times f of x plus 2, 2 times f of x plus 2 cancel. then you left with f of x plus 6 plus f of x minus 2 is equal to, give this to number equal to 0, give this to number 3. Now what you do is, give this number 3. Now what you do is, in third relation, replace x by x plus 2. Then what you get, f of x plus 8 plus f of x is equal to 0. That implies f of x is equals to minus of f of x plus 8. So, but our period definition is what? See, y is equal to f of x is a function if there exists a positive real number t such that f of x plus t equal to f of x for every x belongs to R, then we say that the t is the period. So here f of x plus 2 is equal to f of x, but here we got f of x plus 8 is equal to minus f of x. So, but we need f of x plus 2 equal to f of x form. Now what you do is, now in this one again replace in this above relation, if you replace x by x plus 8, x by x plus 8, then what you get, f of x plus 8 is equal to minus of f of x plus 16. So now from this relation, f of x plus 8 is plus f of x equal to 0. From this relation, f of x plus 8 is equals to minus of f of x. So you replace this f of x plus 8 with f of minus of f of x here. Then what you get, minus of f of x is equal to minus of f of x plus 16. So here minus minus cancel. Then what you get, f of x plus 16 is equal to f of x. So now we got in this form, that is f of x plus t is equal to f of x form. If f of x plus t equal to f of x, here t is the period, t is a positive real number. Here we got f of x plus 16 is equal to f of x. Therefore, here f of x is a period and its period is 16. Therefore, f of x is periodic and its period is 16. So this is the proof.